Today we're going to be demonstrating some tools in MeshWorks in regards to the tire modeling. I'm going to briefly give an introduction in regards to the content and what we'll be covering today. And I'll go ahead and get started. So basically the content is, for this webinar session, we're going to mainly focus on different tools in MeshWorks that can be used for tire modeling. MeshWorks has the functions and capabilities that helps the engineers from a validation and modeling standpoint, be it automotive, off-road, commercial, or for any kind of commercial tire application. For those attending the webinar for the first time, we're going to give a brief introduction on what is MeshWorks and what are the key differences between us and our competitors. We'll also demonstrate functionality that enables the user to generate FE models that capture the complexity of different tread patterns. Then we're going to showcase our hex mesher tool and how it helps generate a good quality hex mesh that can be used for the validation process. We'll also discuss some of our ideas on morphing and parameterization and how MeshWorks can be used to quickly generate n number of designs that will help analyze different tread patterns. The last portion of this presentation will then touch on the value proposition related to the tire industry. So here we're going to address how does the tool set in MeshWorks address the high quality model creation for the validation of your tires in virtual validation process. We'll also discuss what is the MeshWorks data parameterization and how it's relevant for tire performance and optimization. And again, for those of you who are joining this webinar session for the first time, we'll quickly give an overview on what is MeshWorks. MeshWorks is a proprietary CAD and CE platform tool that gives the user a very good tool set for CE model building. It helps in model integration for any kind of MDO, catering to several industry verticals such as aerospace, automotive, engineering, and also the biomechanical industry. Basically, just to give a brief overview, so far, MeshWorks was typically known as a CE morphing module, equipped with design enablers to help for your tuning and your structural models for any kind of optimization processes. Now presenting MeshWorks 8, we've added a bunch of different new modules. We've added the CE CAD integration module. We've added the pre-processing module. We've also added the process automation and engineering analytics. So now we've basically generated and created MeshWorks to be a complete integrated CE platform tool. So now what is MeshWorks? So MeshWorks basically helps in reducing the FEA model building time, and it then forms a very good link between the CAE and your design teams. So it helps in any kind of MDO optimization, helping meeting weight targets, and also minimizing product and weight in terms of minimizing manufacturing cost. So some of the key differentiators in MeshWorks, basically our tool is basically separated into 4 different main pillars. The first pillar is MeshWorks is a parametric modeler, meaning that when you do the meshing inside of MeshWorks, the models become automatically parametric. The tool is also an integrated modeler, meaning that it can take one CAD database and generate multiple attribute models. MeshWorks is also an automated modeler, which you'll see some examples here in the demonstration today, to where we can take very tedious and time-consuming processes and we can reduce it down to very minimal inputs, giving a 2x and sometimes a 10x time savings. MeshWorks is also an associative modeler. It creates a very tight association between the CAD and your mesh. For example, if you have a complete mesh model and your CAD geometry updates, the tool is very intelligent to where it can identify the new surfaces that's been updated or added into your CAD model. It will only mesh those surfaces and integrate those surfaces into the mesh model that you have, so you don't have to basically throw away all the mesh and all the context that you have created for this entire pre-processing portion of it. And it's also bidirectional, meaning that if the mesh updates, now you can take those changes from the mesh and you can nicely pass those changes onto your CAD model using our CAD Morpher tool. So now with respect to the tires, tread patterns are obviously very complex in nature and modeling and can be very time-consuming process depending on which configuration that actually needs to be studied here. The tool set in MeshWorks will also help in creating discrete models which can be used for low-frequency analysis, and also MeshWorks plays a very vital role in regards to model parameterization. Different models can be created to assist with the tuning process to ensure that the engineers can get a better correlation compared to analysis results and the physical testing. Now moving on to the 2D aspect, today our team is going to show how MeshWorks can be used to very quickly create a 2D model that can be used to study various load cases and how the tire can be further optimized as well. Once the evaluation is done on the 2D model, the analyst can then move on to a more detailed 3D model, which we'll discuss here shortly. So in this slide here, you can obviously see that we're going to demonstrate the 3D hex mesh model capability, where we can take a small portion of the tire tread and show how the software is able to generate a high-quality hex mesh. We're going to demonstrate to you guys how such model can be quickly parameterized using the morphing tools inside of MeshWorks. So on to the morphing and parameterization aspect of it. We're also going to show you how we can do the morphing and parameterization on the 2D and also the 3D models. And then once the models have been generated, we want to create a runnable data deck with all the required loads and boundary conditions in order to analyze the baseline performance. Once the baseline performance, or once the baseline results have been evaluated, now the user has the option to create parameters to further optimize or study like what-if scenarios. Now with respect to the 1D, we're also going to highlight different tools in MeshWorks that helps in creating discrete models which can be used for the low frequency MVH load cases, and we can also parameterize the properties of the springs for such models. Now, our team is now going to show you all the tools and functions inside of MeshWorks that's going to assist you with all the model and parameterization. So now I'm going to turn it over to Paresh to give you guys a live demonstration.
Thank you so much, Ray. I'll quickly share my screen now. Okay. So our first demo would be on 2D modeling of a tire for stiffness analysis. So here we see a CAD input data which we get from CAD engineer for 2D modeling of a tire. So this cross section would be an end-to-end section where the inner portion of the tire would be for pressure load area and the outer portion would be for the car cast. And also we see here some CAD curves inside. These are nothing but the reinforcements of the tire. Now once we get the CAD input data from the engineers, so what we can do in MeshWorks is we can create a CAD surface and we can do the trimming of the curves onto the CAD surface, like what we can see here. So very nicely, it's just one-step tool, and once the trimming has been done on the CAD surface, we'll nicely go and organize our CAD into different components. So these different components are nothing but the reinforcement where we will be applying different materials and properties onto it. And also when we do the meshing, there will be different components with respect to the reinforcement. So now I'll quickly show you meshing in MeshWorks. So user just has to select the CAD surface, give the meshing input data, and simply click on preview. Now you can see very nicely the mesh has been created with highly chord dominant mesh. I'll simply click on accept. Now by using our mesh quality control parameters, we can very nicely go ahead and do the mesh flow correction as per our requirement. We also have few tools, mesh editing tools, which are very useful while doing the quality correction, like shell remesh, mesh flow correction, split combine swap. So in split combine swap, we have a swap option where you can just swap a tria with a chord, like you can see on the screen. Then we have remove tria. So whenever we have an opposite tria, or when you have a tria which you have to remove it from your mesh, which has an edge nearby to it, simply click on the tria, middle click, and just remove it. So MeshWorks will very nicely go ahead and remove the tria as if it was not there. So again, we have other options like align nodes, replace node, swap, smooth, move tria. This move tria is also an advanced tool where user just has to select on the tria so that it will highlight a path where this tria can move from one location to different location. So let's say I click on this tria and I select on any other highlighted element, and it will go ahead and move like this. So by using this advanced tool, user can very nicely go ahead and create a smooth and high quality mesh. So once the meshing has been done in MeshWorks, so what we can do is we can create or we can assign material and property automatically. Meaning that let's say we have a component and we don't have materials and property been assigned, and we have n number of components in our model tree. So we have a process automation tool where we just have to select the component CSV file, the material CSV file, and simply click on create and assign. But before that, I'll like to show you exactly what's in the component CSV file. So here we have all the component names which are in our model tree. With respect to the component name, we have assigned property type, thickness, property name, and material type to each and every component. So likewise, when the first component has been called, it will assign the material, and we have a material library that is nothing but the material CSV, where you can put all your material information into it. So once you have both the files, simply click on create and assign. It will go ahead and very nicely go ahead and assign material and property to each and every component. So I'll change my selection mode to properties, and I'll pick one of the component, and as we can see, it is assigned. And if I say review, so we can see how nicely it has assigned the material to the property. So this is how we can robustly we can assign material property. We can do the meshing, we can do the mesh editing, and also by using our advanced tools, we can assign load cases, boundary conditions, and set the model for run. So once the model has been set for run, we can also create some parameters onto the model. So I have created few of the parameters by using our morphing technique in MeshWorks. So the first one is inner width, where I would like to increase to my higher bound and lower bound, where you can see how nicely I can increase or decrease the material for the inner width, and also at this particular edge there would be pressure load area, so we can adjust our pressure loads too. Then the next would be outer width. I'll hide my control nodes and deformable nodes. So as we can see here, how nicely we can increase and decrease the outer width too. So this will help us to reduce or increase the material and to find the optimized model. Also, we have few parameters like thickness, where user can nicely increase or decrease the material of each and every reinforcement and create a DOE. So we have n number of parameters been created. I like to show the last one. So this is how nicely we can create a parametric 2D modeling. And once the parametric model has been created, we can link MeshWorks with EyeSight, ModeFrontier, or any other optimization software so as to get an optimized model of a tire. So this was all about the 2D modeling. Now I would like to switch to 3D modeling. So as we see here, this is a small portion of a tire thread, and we would like to do hexa meshing for the tire thread. So for this, we have created a special tool, that is tire automation, and we can see we have just minimal inputs. From this minimal inputs, we can create a good tire hexa mesh. So before starting to do a meshing, I would like to go ahead and do organizing I like to organize the CAD into different collectors, so that in next steps it would be really helpful for me to execute the steps. So first I would like to organize my top surface into different collectors. So I'll give a name. Then I'll organize my bottom surface. Then I'd like to select one side face with one side of groove attached to it. So I'll not give a name, but just say move. So I'll do auto color so that I can see my CAD into different colors. So now once the CAD has been organized as per our requirement, we would like to go ahead and click on single pitch hexa meshing, where we would like to create a cross-sectional surface mesh. So here what exactly the process is, we would like to go ahead and create a surface at the face and imprint all the features onto that surface so as to get a nice meshing. For that, I would like to select my axis, my center point, then I have to select my width CAD points, then I'll select my extreme end points, and then surface to imprint. So this is the side face which I need to select, and simply click on create cross section. So here it will create a surface, and also with respect to that it will nicely go ahead and trim it as per the features which we see here. So I'll turn off. So now once we get a very nice side mesh, I would like to go ahead and do some editing of CAD surface. So I'll just go into edit CAD surface, line and point. So here I'm just trimming or discretizing that CAD surface into different or into small surfaces so as to get a very nice chord dominant meshing. So once my CAD editing is done, I would like to fill my grooves too. So we have a process automation or a tool for filling the grooves, where I would like to select my line by path and simply say fill groove. Similarly, I like to go for the next one, and similarly I can go for all other grooves and fill it up. Once my setup has been done, like CAD, like surface editing and filling the grooves, I would like to go ahead and do the meshing in MeshWorks. So I'll select my CAD surface and simply say preview so that I'll get a nice chord dominant flow here. I'll turn on my show seed points, and here we have a nice tool that is a reseed edge, where I can nicely go ahead and edit or change my seeding points on the edges. Similarly, I'll go ahead and put some seeding at the edges and click on map mesh. So it will go ahead and very nicely create a chord dominant smooth mesh. Similarly, we'll go ahead and do similar for all the surfaces, but as per interest of time, I would like to go ahead and switch my windows where I have created my mesh beforehand. So as we can see here, how nicely all the features are being captured as per the tire. So once we get the side mesh where the features are been nicely identified, we would like to go ahead and create a swift hexa mesh, and also we would like to create a top surface, CAD surface, where now instead of side features, all the top features will be identified and imprinted on the new CAD surface. So for that, I would like to select my CAD surface, the tire CAD surface, my top surface, bottom surface and simply create top surface. So it will go ahead and create a hexa mesh. I would like to turn off my 2D and turn on my wireframe CAD. So here we see how nicely the mesh which we created from here, it took the features of the CAD and it swept along the geometry of the tire. Now here it has also created one more CAD surface at the top, but the mesh is not aligned to the top surface with the hex mesh. So our next step would be to mesh the top surface.
So if you go ahead and turn off the hex mesh, and what we want to communicate here is, go ahead and display the top mesh. So now basically what we need to do is we need to temporarily create a mesh here that's going to capture these features. Because what we want to do is we want to basically propagate these features in the opposite direction. We've captured the features in one direction, and now we need to capture the features in this top direction as well.
So now what we're going to do is we again going to go into measure panel and do the meshing for the top portion. So I'll quickly click on preview, and again by using our reset options we'll get a very nice chord dominant mesh onto this CAD surface. So now the mesh has been completed. So with interest of time, I have created the mesh also for the top surface. So I'll move on to my next window. So now here I'll just turn off my 3D and turn on my 2D. So now here I can see how nicely our 2D mesh has been created with all the features been nicely captured. And if I see my 3D is not been aligned with the features as we can see here. So to align, what we have an option that is imprint top mesh, where it will go ahead and imprint or propagate the top mesh onto the hex mesh so as to get our final output. I'll turn off my 2D. So now we can see how nicely it has been imprinted, and from top and also from the side. So this is how quick hexa modeling of a tire has been generated. So as here we had some grooves, so we don't have to worry about it. We don't have to do it manually. We have an option that is isolate hexa, where we just have to click on isolate hexa and it will automatically identify the grooves and keep all the elements or all the hexa elements into different components. So it takes around 2 to 3 minutes. So with interest of time, I'll switch on to the next window. So this is the output of our isolate hexa, where it will nicely put these grooves into different components. So once the output model has been generated, we would like to go ahead and create a 360-degree hexa meshing, where user can select the component, user can select the center node and the axis, where software will automatically identify the degree and it will give a revolved hex mesh of a tire. So with interest of time, I have created this beforehand so that we can save some time. So this is our final output of 3D revolved hex mesh of a tire.
And we also have a process to where, in some cases, the pitch may change. We also can actually control the pitch. We won't show it here in this particular example, but just to give you guys some idea that we know that there's going to be some situations to where the pitch is going to actually be different, and we can nicely have control over that as well.
So now if we have to do some meshing or we have to do some morphing on the cut section which has been created, like here, so we have created some parameters. So I'd like to go for the first one, turn on my control nodes and deformable nodes. So here we can see how nicely I can morph a hexa mesh and how nicely I can increase or decrease the thickness of a tire. Similarly, I can increase or reduce the profile change. Then I have tire section change, where I can nicely go ahead and change my section. Also, if we are very much interested in the grooves, we can do morphing on the grooves too, where I can increase or decrease the thickness of the grooves, as we can see. And this morphing is happening on a hexa meshing. This was for the height, where if you have to increase the groove height. So now this morphing would be useful if a company or if a user has an old mesh and he has to match it with a new CAD geometry. So by using the morphing techniques, a user can match the old mesh with the new geometry. So here we can reduce modeling time to build the high quality complex thread pattern model in MeshWorks by using some advanced tools and process automation. So now I'll switch on to Ray.
Thank you so much, Paresh. So give me 1 second so I can share my screen here. Okay, thanks, Paresh. So basically what we want to highlight is what you're actually seeing on the screen is a technical paper presented by tire experts, where MeshWorks was actually used to study different profiles to evaluate the effect of hydroplaning in this case. DOE approach was used here for this study, but here the user can use optimizers such as EyeSight in order to generate DOE samples, or MeshWorks actually now has the capability to generate the DOE samples using the optimal Latin hypercube method. So you can see in this example, the user has analyzed the baseline model, and he's generated a DOE using EyeSight, Mode Frontier, or you can also use MeshWorks to also generate your DOE samples. So they've taken the best DOE design. You can see here, this is the best design that they've gotten from the DOE samples, and they use an optimizer in order to get a more optimized design, which you can see here in regards to the static pressure and also the velocity output. So basically, we want to highlight the key value propositions of MeshWorks 8. Obviously, there's drastic time reduction for model building for the mesh models for your virtual analysis, and the CE modeling time and the tools used in MeshWorks helps create a very, very good high-quality hex model for any kind of analysis. You guys were able to see the process automation inside of MeshWorks, which is very, very easy to use. And the CE process can yield a 2x and sometimes up to a 10x time savings. And we also was able to demonstrate how MeshWorks can nicely create a parametric model that will help in optimizing of the tire tread patterns to study any kind of what-if scenarios in terms of groove depth, the block width, sidewall stiffness, things of that nature, to where the user typically wants to evaluate different designs and different tread patterns in order to get a more optimized design. So this will conclude our tire presentation today, and we really want to thank everyone for joining. And now we're going to open up the floor for any questions.